Hello my dear students. In the last lecture we have discussed that how to use DC generator in order to produce the electrical power, because electrical power is required to drive all the essential electrical amenities or the electrical accessories in an automotive system. Not only that, using that electrical power we need to charge the battery also. That is one of the major requirements. So how do we do that? That has been already studied, and the basics of DC generator has already been studied. But the thing is, you see that the DC generator, it is charging the battery. Suppose you have a DC generator G like this, which is connected to a rechargeable battery. So what will happen? So the power will flow to the battery and the battery will be charged. Let us assume the upper terminal is positive, it is larger, and the lower terminal is negative. So what will happen? The battery will charge, the electrolyte will be storing electrical energy in chemical form. But what happens if this current is very high? And if this current is very high, what will happen? It will cause severe damage to the battery. So we need to control the current. So controlling is one of the most essential and one of the most important things that should be employed. So if the excess current is not controlled, the generator would continue to push it through the battery, causing the electrolyte to overheat. So excessive gas will take place inside the battery, so boiling the electrolyte out of it, thus ruining it. Obviously, there are means of controlling the excess generator output. So this is the function of a mechanical voltage regulator. So we need a voltage regulator. So a mechanical voltage regulator is supposed to regulate the voltage in order to control the current. That is one of our primary tasks. So as noted earlier, the field coils of the generators become magnets when current flows through them, obviously. So if this is a coil, say, so if this is a metal or a magnetic material and field coils are wound like this, and if you supply voltage, so what will happen? Current will pass through the coils, and what will happen? A polarity will be induced like this. Suppose the upper end becomes the north pole and the lower end becomes the south pole, like this. So as noted earlier, the field coils of the generator becomes magnets when current flows through them. So what if you could turn them off, the current at the field coils, when the battery is fully charged? So when the battery is fully charged, we did not regulate or we did not direct the current to the battery. So what would happen if you can just turn the field coils off? And what if you could turn the field current back to the system when the voltage starts to drop? So this is exactly the mechanical voltage regulator does. So let us see the process. So the current from the generator field coils must pass through a set of movable points called the voltage regulator. So when the points are close or touching, the current flows. If the system gets too high, battery is fully charged. So a specially calibrated electromagnet in the voltage regulator becomes strong enough to pull the points open, shutting off the current to the coils. So the field loses its magnetism and the generator stops generating. So we have to just disconnect the field power supply so that the field doesn't work and the magnetic field does not exist. So if the field loses its magnetism, what will happen? the generator will stop generating and the battery will not be overcharged. So as soon as the system voltage drops below the calibration point of the electromagnet, the point snapshot again, energizing the field once more. This regulation process happens constantly at a rate of say 200 times per second. So it effectively limits the generator's output to provide only what's needed to power the electrical loads and maintain the full battery charge. Strictly speaking, a voltage regulator consists of an electromagnet and a point set just discussed. So these are mounted on a metal housing which also contains a current regulator. So the entire unit is commonly referred to as the voltage regulator. So this is the description of a voltage regulator. So the current regulator comes into play when many loads are working and high generator output is needed. So in this particular case, the voltage regulator stays out of action, permitting maximum generator output. But besides these circumstances, it's not possible for the generator to work so hard that it burns out itself. So the excess current flow is the culprit. So somehow we have to control this excess current. So excess current is one of the major disadvantage which may cause damage to your system, and you have to be careful regarding that. So a second calibrated electromagnet and point set in the voltage regulator housing should be there, which temporarily cuts off the field current in the generator so that the output current flow is too high. So a point set should be there. So a reference point should be there. So suppose the point set, or if I write it as PS, it is set to be as say, let us say it is 5 ampere. Now what is happening? Your field current IF, it is going on increasing. So 0.5, 1, 2, 3, 4. So as soon as it reaches 5, what will happen? The field supply will be cut off, because this 5 will equal to this particular 5. So if they becomes equal, what will happen? Your field current will be cut off and your field will no longer be energized by the field current. And if the field current is not there, the generator will not excite. And if the generator doesn't excite, what will happen? You will not get any voltage at the output. So this is how you control the output current flow. So most mechanical voltage regulators are used in these recent years are not adjustable. So there is nothing you can do to calibrate one of the internal components that gets out of specification. So earlier models are adjustable. So consult the appropriate shop manual if you see your says. So AC generators use electronic voltage regulators. So this is one of the advantages of AC generators, because there is a provision of something called field current control or the excitation control, which is possible in an AC generator. So that can be done. So let us study an AC generator. So in the early 1960s, the demands on the car electrical system had to be great, so that the DC generator could not handle. So the alternator was developed. So AC generator, it is also called an alternator. Why? Because if you see the AC nature, its nature is alternating. So for the first half cycle it is positive, and for the second half cycle it is negative. So the output of an AC, it is always changing with half a time period. So that's why as it alternates, so an AC generator is also called a alternator. So it is much more efficient than a DC generator and is able to provide a great deal of current even at engine idling speed. So like a DC generator, an alternator supplies a relative movement of a wire loop and a magnet to create the current. So the relative motion between a wire loop and the magnet is there, which will just create the current. But there are some major differences. In an alternator, the magnet rotates while the wire loops are stationary. So the magnetic system will rotate and the wire loops will be stationary. So to provide electricity to make the magnet work, an alternator uses carbon brushes operating against continuous slip rings, and they are not segmented like commutator. So in DC machine we have already studied what is called commutator. They are just copper segments which are separated by mica sheets, and brushes are compressed on those segments so that currents can be collected, unidirectional currents can be collected. So here you do not need mica segments, rather you will require slip rings. So this is the major constructional difference. So this means that the magnet gets a constant supply of battery voltage. So no matter what position it is rotated to. So the wire loops are arranged in the generator housing so that rotating magnetic fields cuts through each loop in turn. So this is the operating principle. But because rotating magnet has north pole and south pole like any other magnet, each wire loop gets a shot of north followed by a shot of south. So these becomes alternating on each revolution. So remember that the flow direction of the induced current depends on the direction of the magnetic field or movement. So each loop will get current induced in one direction. So each loop will get current induced in one direction. Then the other is producing the alternating current. But auto electrical systems operate on DC, not AC. You have to remember this. So the breakthrough is made alternator practical for use the DC electrical system if an electronic device called a diode. So if you have an AC, so what will happen? The diode will only pass unidirectional current like this. So suppose you are having the input like this, so the output will be only this. So the negative cycle will not be there. So that is called rectification. So this is a revolutionary device, which is a very simple device, but yes, it is very impactful, you can say, which is giving you unidirectional power, and that's why a diode is very, very important. So next comes electronic voltage regulator. So although the alternator originally was teamed with a mechanical voltage regulator, engineers soon found a way to transistorize the regulator function. So this led to the development of all electronic voltage regulator. So initially it was mechanical voltage regulator, now it is electronic voltage regulator. So in time its size was reduced to the point that it could be installed inside the alternator housing. So it could be installed at the alternator housing. So it has no moving parts and it's not serviceable or adjustable in any way. If the voltage regulator becomes defective, you have to replace it. However, electronic components are extremely reliable and replacement is not oftenly required. This is the advantages. You do not need any frequent replacement. That advantage is always there and you will be getting that advantage. So I think the difference between an AC system and a DC system is clear to you. AC evolved much later, maybe implemented in the automobile after 1960s. Before that DC was there. But in an AC system you need a field system, where again you need a DC. But you cannot just have to afford two supplies, so you have an AC supply, and for that you used a diode to just rectify, and you just generated the field current from that. So that is again another revolution made by the component called diode. So we will stop over here for today. See you in the next class. Thank you.